In section 1.8, we'll begin working with our first derived quantity, density. If we know two of the three quantities that make up density, we can solve for the missing piece and even identify a substance based on the value we calculate for density. The learning outcomes match the author's learning goals on the previous slide, so let's begin. Density is a measure of how much mass something has relative to how much space it takes up, its volume. Objects that are less dense float in fluids that are denser. Weather is the result of air masses with different densities interacting with one another. Earthquakes result from the movement of Earth's tectonic plates as the lower density crust floats on the moving mantle, which is denser beneath it. Density is defined as mass per unit volume, or just D equals M over V. Density units include both mass and volume units, such as grams per milliliter or grams per cubic centimeter. Density values can be used as conversion factors between the mass and volume of an object. Given the description, can you tell which is denser? Suppose that objects A and B have the same volume, but A has a greater mass. Which is denser? Object A has more mass per unit volume, so it has the greater density. Suppose that objects C and D have the same mass, but C is larger. Which is denser? Object D has more mass per unit volume, so it has the greater density. Density is an intensive property, so it doesn't matter if you have a large piece of aluminum or a small piece of aluminum. While the masses and volumes will differ, the density remains the same. For this reason, we can use density to help identify a substance. Let's look at how to use density in calculations. Suppose you have 41 milliliters of mercury. We can use the density as a conversion factor to calculate the mass of mercury. We set up the problem with the information we're given, milliliters of mercury, then use the density to get rid of the unit we don't want, milliliters, which goes on the bottom. The unit we do want, the mass, goes on top of our conversion factor. We're given three significant figures, so we'll round our answer to three significant figures as well. Calculate the density of a piece of wood in a certain desk if its mass is 41.6 kilograms and its volume is 51.3 liters. Give your answer in both kilograms per liter and grams per milliliter. Would this desk float in water? Let's calculate the density in kilograms per liters first. Density equals mass over volume equals 41.6 kilograms over 51.3 liters. We get 0.811 kilograms per liter. We can then convert from kilograms to grams and liters to milliliters and do the same calculation. Alternatively, we can take the kilograms per liter answer we got and convert those units to grams per milliliter. Either way, we see that the density of this wood is less than the density of water at 1 gram per milliliter, so it will float on water. I'll leave you with the parting thoughts of the authors.